Welcome everybody to the October 2021 Novice meeting of the Houston Astronomical Society. I really appreciate everybody joining on a Thursday night. We are close to new moon, but unfortunately I'm looking outside the windows now. There are quite a few clouds, so I don't think anybody's missing out on any observing tonight. However, since we can't observe, we're going to do the next best thing, and that's listen to our novice chairperson, Ms. Debbie Moran, talk to us about how to do observing and other things like that, what to observe, right? So without further ado, I would like to introduce and pass it over to Debbie Moran. Debbie, take it away.
Okay, thank you very much, Joe. So tonight, I was going to talk about putting your observing in context. I learned pretty early on when I was an amateur astronomer that everything I was looking at in the telescope was really just a piece of a star's life. And that really made it a lot more interesting to me once I understood what I was looking at. So this is actually the first novice talk I gave about 5 years ago, and I decided to pull it out again. And so I'm going to go ahead and share my screen. Is that okay, Joe?
Certainly.
Are you still working on Facebook, or just go ahead?
Go ahead. I don't know if it's going to come up tonight.
Okay.
I'll need to make some adjustments there.
Okay. All right. So I'm going to share my screen.
Certainly. And just a reminder to everybody as Debbie's bringing her screen up, if you have any questions that you want to ask, please use the chat feature within Zoom. We'll go ahead and queue those messages up as they come in and get to those at the end of the presentation. So go for it, Debbie.
Okay. Everybody see that? Or Joe, is my presentation on the screen?
It is. We can see it.
Okay. All right. So I call this talk Putting Your Observing in Context, the Life and Death of Stars, because that's basically what you're looking at when you're looking at the telescope, or some part of a star's life. So I'd like to start out a little bit with the evening sky map for October. There is a website called Sky Maps with an S, skymaps.com, where every month you can download a map for the Northern Hemisphere for the early part of the evening. This will only work for maybe the first hour, hour and a half after dark. And I wanted to show this first because a lot of the objects we're going to talk about tonight are on this map. You would be able to see them in the early evening. And I'll just highlight a couple of areas. I did talk about some of these constellations in more detail a couple months ago, but you'll see a dotted line in the middle, and that is highlighting three bright stars, Deneb and Cygnus X1 and Vega and Lyra, and also Altair and Aquila the Eagle. And these three bright stars are called the summer triangle, and that's because they're up all summer. But it actually turns out that autumn is the best time to see it because it starts out very high in the evening, early in the evening. And we'll be talking about some of these constellations along the ecliptic, the familiar constellations of the zodiac. We'll be talking about some objects in Capricornus, where Jupiter and Saturn are, and Aquarius, Pisces, the teapot, which is part of Sagittarius, and Cetus the whale. Take a note of that. I'm going to come back to this map at the end of the talk just to point out some of the things we've talked about, but just some little basics. Once you download this map, you'll notice there's some directions along the edges, east, west, north, south. They're all topsy-turvy. What you would want to do is turn the map in the direction you're facing. So if you're facing north, you'll turn the map upside down. So north reads at the bottom. And then recognize that the stars in the middle of the map are directly overhead. And everything in the bottom of the map, the way you're facing, so for right now I have it oriented as if we were facing south, all these constellations on the bottom half of the map will be will be right side up for you. And you don't worry about the ones at the top of the map because they're behind your head. Then you just reorient when you need it. Let me go ahead to my first slide. Starting out with stars, they are born in the spiral arms of spiral galaxies. So this haze here from the Andromeda Galaxy is creating stars. That's where they are formed. And we have billions and billions of galaxies in the sky, as we know from the Hubble Deep Field. So we're just in one of them, and we're about 2/3 of the way out from its nucleus. And like the Andromeda Galaxy, we also have a couple of companion galaxies called the Magellanic Clouds, and which you can see in the southern hemisphere. So I'm going to start out with the Andromeda Galaxy because this is the farthest you can see with your naked eye. When you look at the Andromeda Galaxy, you're looking 2 million years in the past. And it is naked eye as a faint smudge if you're in a dark sky. You cannot see that in Houston, but it will stand up to some brightness in binoculars or in a small telescope, even in Houston. And it just won't be quite as impressive. So Andromeda Galaxy is named for the constellation it is in, which is the constellation Andromeda, which is sort of a cascading line of two lines of stars that curve, and they're coming out the Great Square of Pegasus. And you'll be able to find this on your map later. Once you find these cascading stars, and they're sort of underneath the W of the constellation Cassiopeia, which is very clear in the sky, you start out with the corner of the box and you find one pair of stars, then there's a second pair, and then there's a third pair the farthest out, and I'm hoping you can see my cursor. Go back to the second pair, and you go to, referencing off of the W event of Cassiopeia, you go to the bottom star, the top star, and then exactly the same distance to Andromeda Galaxy. So it makes it very easy to find. If you can find these two stars naked eye, you can just use them as pointers to Andromeda. So one of my very favorite galaxies other than Andromeda is NGC 253, and that is low in the sky at the beginning of the evening, but should be visible this time of year. It's known as a silver coin galaxy, and this is the one that looks most classically like a galaxy, even in a small telescope. It has the most texture I've seen. I started out in astronomy with a 5-inch telescope, and this is one of the few galaxies that really looks like a galaxy, even a 5-inch telescope. So it's always a good idea to look at NGC 253. But again, this is just another angle of a spiral galaxy. And here's a face-on, which is also in the sky now, called M33. It's not far from the Andromeda Galaxy, in a constellation called Triangulum, which is one of the few not marked on the map, but I'll show you at the end of the talk where that is. It's near the constellation Aries, and it's a little triangle of stars, and you'll see M33 there. By the way, when you're getting information about these objects online, or if you want an image, be sure to put what it is, M33 Galaxy or M15 Globular Cluster. Otherwise, you will get a lot of images of assault weapons, so be careful with that. So here's M33, here's the constellation Triangulum, which is exactly what it sounds like, a triangle, sort of a long isosceles sort of triangle of stars that are fairly clear to see. And M33 is near this triangle. Now M33 has what we call low surface brightness. So even though it's a large galaxy and it's face on, it's spread out all over your eyepiece, and it's a large but not very bright object. So it's considered a bit of a challenge, but it will show up in a dark sky in a small telescope. And here's what I'm going to use this galaxy to talk about where stars are formed. So you see on my screen, it mentions H2 regions and with a Roman numeral 2. And those are these reddish knots that you see in this detailed view of M33. And these are areas where brand new stars are forming. And I'll show you that a little bit closer up. We have them in our own galaxy. And those are some of the best things to look at in a telescope. So what's happening is you've got clouds of hydrogen, mostly hydrogen gas, and some other elements, helium. And if any stars have formed before the current generation of stars and lived and died, which we'll discuss later, they might have exploded some of the elements that they made into that gas cloud. And then that might push some of the atoms closer together, cause some shock waves, and the gravity will start to take over and new stars will condense out of that cloud of gas. So this is a protostar. We now know that Hubble has been able to see stars literally in the process of being born in the Orion Nebula, which we will come to later. And they actually see what they call these tadpoles, or what looks like little proto-solar systems. You don't even have planets yet, but the star is spinning. There's jets forming, and we believe that this is the birth of a star or a solar system within these clouds. This is the Orion Nebula, which is not up yet, quite yet in the early evening, but is up later in the evening and will become an early evening constellation in just a couple months. And so within the constellation Orion, you see one of the most impressive sights in the northern sky called the Orion Nebula. And notice you don't see a lot of stars in it. So this is a photograph. You'll see what looks like kind of glowing cigarette smoke in your eyepiece. And within it, you'll see a few stars embedded, but many of the stars are behind the gas and dust of this nebulosity. But when you're looking at the Orion Nebula, you are looking at a birthplace for stars. So this is the nursery of stars, or baby stars. The Orion Nebula is about 1,500 light years away. So you were looking 2 million years in the past. With Andromeda Galaxy, you're looking only about 1,500 years into the past. That's how long that light took to get to your eyes. So that is located in the constellation Orion, one of the most famous constellations because he looks like a man. There's 2 shoulders. You have a red star here, and you've got Bellatrix over here. This is Betelgeuse. And then the other star that's most prominent is the blue giant Rigel, which is the bottom right foot. And there's a star here that's the other right foot. Then there's the famous belt stars. But the Orion Nebula is not in the belt. It's in a small string of stars hanging down from the belt, which are like the Orion's dagger or sword. And about in the middle of that small string of stars is M42, which is the Messier number for Orion. And that's where you would locate the Orion Nebula. It is good enough to see in binoculars, even in the city and in a small telescope, but of course it's more impressive in a dark sky. But it's one of the few nebulas will stand up to some city lighting, and is great to show at star parties with kids. Another star forming region, or a couple of others which are not up this time of year, but are summer objects, are the Trifid Nebula and the Lagoon. So the Trifid's on the left, and it's named Trifid because of these 3 dark lanes, which divide the 3 pieces, or Trifid. And then there's the Lagoon Nebula, which is actually named for this dark area between the star cluster here and some nebulosity, which some people thought looked like a lagoon. This picture blows it out a little bit. You would definitely see a dark area here in your telescope. In binoculars, you can see them together, but you won't get this view in a telescope because this is a wide field view taken with special camera equipment. So you can get these 2 details in the same picture, but you don't get that in the telescope. So you can look at them one at a time, but they are so close together. They are these beautiful spangly smudges in binoculars. The Swan Nebula is another of the very best of the places where stars are forming because of its beautiful shape, like a swan or a check mark. Or it's also known as the Omega Nebula because people thought it looked like the Greek letter omega. But again, that's in the summer. It's actually very low at the very beginning of the evening, but we're about to lose it. So these stars, or these areas of star formation, are near the constellation Sagittarius. That actually does show up on your map for the early evening, but Sagittarius will be setting soon. And the top part of the constellation, Sagittarius is actually an archer, looks very much like a teapot. Very much like a teapot with a triangular spout and a handle and then a triangular top. And you find M8 and M20 by going from the left side of the lid to the top of the lid, straight across the Milky Way. You'll actually see some Milky Way here. And you run into these 2 smudges. So those are the Lagoon and Trifid nebulae. And M17, the Swan, is a little farther up the Milky Way. But again, this is not quite the best time of year to look at them, but in the summer when they roll around, they're definitely impressive. So what's happening when these stars are being formed? Once gravity takes over and all this gas is infalling toward the center, gravitational center, the star is basically fusing hydrogen and helium. So the weight of the infalling gas is so strong that you basically have almost like a popcorn popper effect in the center of the star. There's a lot of motion. It's very hot there, so atoms are being smashed into each other. And eventually you have a nuclear reaction in which 2 hydrogen atoms create 4 helium atoms. But the 4 helium atoms that are created weigh slightly less than the 2 hydrogen atoms. And so that mass has disappeared and has been converted into energy. That's where Einstein's equation E = mc² comes from. If you create a very small, take a very small amount of mass and create energy it creates an enormous amount of energy. That's why the atom bomb, which is fission, and the hydrogen bomb, which is fusion, can be so small and yet destroy entire cities. They are creating energy from matter. That's what's happening in the star. And this energy is creating heat and light, which is pushing outward. And eventually the star comes to equilibrium. So the gravity is pulling all the gas inward. The fusion of the hydrogen and the helium atoms is creating light and heat and pushing outward. And these two eventually balance out. And that's when the star is in its stable part of its life. And we have to have a stable star to have an Earth and to have life. So the next step is a lot of that gas gets used up, and the stars that have formed are still in a group. They're still gravitationally bound to each other. And this object is called either a galactic cluster or an open cluster. I usually call it an open cluster. When you see one in your telescope, it's going to be a group of 80 to 120 stars, and it looks like glitter spattered on top of the background star field. Very, very beautiful. There's two, or actually there's more than two, but the two that you can most easily see naked eye without a telescope are the Pleiades. The Pleiades are just beginning to rise early evening at this time of year and become higher and higher as we go into the winter. And that may be the most famous. And then there's also the Hyades, which is actually a piece of a constellation, a piece of Taurus the Bull. And so what's happening is that the head of the Taurus the Bull is a V shape of stars. And actually, if you follow each side of the V and keep going, you'll come to the two horns. There'll be two stars that demark the horns. And the Pleiades will appear to be Taurus the Bull's shoulder. So when you find the V-shaped head of Taurus the Bull, which will be rising slightly after the Pleiades, just slightly off of our early evening map, but is up later in the evening, that head is actually the closest star cluster to us. It's about 153 light years away, and it is the Hyades. So although you might only see Aldebaran in a very light polluted sky like Houston's, or 1, 2, 3, 4, 5 stars naked eye in a little bit darker sky, when you point your binoculars at it, you will see actually those are the brightest stars in the entire cluster. So it's a great binocular cluster, far too big to see in your telescope. There is a wonderful, one of these stars, the star next to Aldebaran, which looks single to your naked eye, in a telescope is actually a set of 6 stars, which you can, on a wide field eyepiece, set 2, 2, and 2, and it's a lot of fun to look at, and it will stand up to city viewing. So here's Taurus, a little bit wider field. You've got the V shape here. This view shows a few more of the stars. If you follow each side of the V, you come to the horns here and here. And remember this horn, because later on we're going to discuss M1, which is over here when we get to Supernova Remnants. And then again, related to the V, here's the Pleiades over here. Now there's another wonderful set of clusters to look at in the telescope this time of year is the double cluster in Perseus. It's the only double cluster I know of where you can take a reasonably wide field eyepiece and a small telescope and see 2 open clusters at once. Normally you're looking at only one. And it's located between the constellations Perseus and Cassiopeia. So here's Perseus. Well, actually, I guess I don't have quite enough of Perseus. But anyway, between Perseus and Cassiopeia, which is up here, about halfway, you would find the double cluster. It'll be on your map. Here's Cassiopeia. So the double cluster is sort of in here. Now, within Cassiopeia is probably the cutest star cluster in the sky. And it's fairly easy to find because it's not actually one of the 5 bright stars, which make the W shape of Cassiopeia, or M if it happens to be upside down. But you can use those stars as pointer stars to a star called Phi or Phi, the Greek letter Phi, Cassiopeia. And you do that by taking the left side of the W, the very left side, going to the bottom left, and continuing the same direction about 1/3 of the way and slightly outside that line. If you're in a reasonably dark sky, you will see a naked eye star. If you're not in a dark, if you're in Houston, you can still find it, a little bit trial and error by knowing this geometry. So here to here, about a third of that distance is slightly outside that line. And you can hunt around with maybe an 8-inch telescope in Houston and see it, even our light polluted sky. So it's the cutest cluster and one of the best to show to children at star parties because it looks very much like ET, the extraterrestrial. This picture goes a little bit deeper than you will see in your telescope. So when you look at a telescope, the first things you notice are the two eyes. The brighter eye is Phi Cassiopeia, which is actually a foreground star. It's not directly in the star cluster, but all the other stars are part of this cluster, open cluster. And it was originally known as the owl cluster because people thought it looked like an owl with two bright eyes sitting on a branch. But modern audiences see it as ET, the extraterrestrial, because in the movie, ET was a little short guy with very wide set eyes, big feet. His feet are down below his eyes. And then he flies through the sky at the end, actually rides a bicycle, but he looks like a little kid holding two outstretched arms. And once you point that out to people, you start them with the eyes and then the dot to dot body to the feet and then the dot to dot arms. I've never had anyone fail to see this. You might be upside down or sideways, but everyone sees it. So once we're in the open cluster stage, now we're in midlife for a star. So I like to discuss the solar system as the best place to see a star in midlife. Our closest star, the sun, Sol, is a yellow star, and I'll talk about star colors in a bit. But what that means is it's a medium-sized star, which will have a medium-sized life. So its expected lifetime is about 9 billion years, and it's about halfway through that life at 4.5 billion years. And it has a planetary system, and we now know that many stars have planetary systems. That's one of the growing fields in astronomy is looking at other stars for planets, and we're getting some great new instruments to do that with. So the James Webb Telescope, when it launches, hopefully soon, one of the things that we'll be able to do is more directly see planetary systems. Right now, the planetary systems are implied by the way they make the star's light drop off and the way they tug at the star. It has a wobble based on the planets around it. So we've already found about 3,200 star systems or planetary systems out there. So one of the things we can notice of the sun is that it's very active. It's got solar flares, especially in this picture. Pieces of the sun rise and fall along the magnetic fields. It's got sunspots where basically you're seeing the same thing, but you're looking at it face on instead of edge on. And when you go see a total eclipse, you will be able to see these on the edge of the moon, of the dark moon, along the edges. If you see a very short total eclipse, like we did in Uganda in 2013, the beauty of that is you don't get to see the eclipse very long, but you see the prominences of solar flares all the way around the sun all at once. With a longer eclipse, like we're going to have in Texas, or actually throughout the United States, Texas up to Indiana, into Maine, and down into Mexico, that's April 8th, 2024. That's going to be a 4.5-minute long eclipse at its center line. And by the way, in case you're interested, the Hill Country is well placed and Dallas is well placed. So cities along the center line are Killeen, Waco, Kerrville. That part of Leakey's well placed. That part of Texas is really well placed. San Antonio and Austin are on the edges. Houston is just outside the path. Not good enough. You definitely want to get yourself inside the path. So for that eclipse, the moon's apparent size, because it's elliptical orbit, is going to be large enough to cover the sun more completely, but you will still see these prominences come in and out sequentially. So another way to look at the sun in midlife is to look at its planetary system. So Mars is not especially good in 2021, but I did want to mention that it's one of the best things you look at in a small telescope, but mostly when it's especially close to us. And Mars alternates on its opposition. So it's always a time every 18 months or so when it's closest to us in our orbit, but for 1 year its closest approach on the orbit is a little farther away, and then the next year it's close by. So 2021 is a dud year, 2020 was a good year, and so on. And so in another 18 months, hopefully we'll have a good opposition. Saturn and Jupiter are very well placed right now. We talked about that a couple months ago. And so if you want more details, we have a talk online and on YouTube YouTube for that. So I do recommend definitely looking at Jupiter and Saturn. They're a little bit past opposition, which happened in August. But what that means is, although we're a little bit smaller, they're a little bit farther away from us now, they're higher up in the sky in the early evening. So it's actually one of the best times to look at it if you do most of your observing earlier in the evening, because planets look far better when they're higher in the sky, and they won't wobble so much when you're looking through a lot of atmosphere on the horizon. So I wanted to talk a little bit about the next stage of life. Once a star starts to run out of the hydrogen that's fusing into helium, it will start to do fusion again, but it does it farther out. So, so what happens is that fusion is happening in a shell around the nucleus of the star. And so the hydrogen is becoming helium, it's creating light and heat farther out. And that heat farther out from the center starts to push the gas outward on the outer layers of the star, and it will expand into a red giant. So the redness means the star is cooling. When something expands, it also cools off. So a great place to see a red giant is in Orion's left shoulder. And Orion will be prominent again in the winter. So I like Orion to see star colors because the red giant Betelgeuse in the left shoulder contrasts very strongly with the blue giant Rigel. And a blue star is a very hot star. And in the case of Rigel, what that means is that it's just an especially large star, which is running through its fuel very, very fast. With kids, I compare it to a popcorn popper running at super high speed. So a blue giant star crushes its hydrogen into helium so fast it only lives millions of years, whereas a red giant is a star that started out as a yellow star like our sun, and now is later in life and starting to burn the hydrogen farther out from the center. When the sun becomes a red giant, it will probably go out to about the orbit of Mars. So don't scoff at these, you know, the Elon Musk of the world or the Stephen Hawkings of the world who think eventually we need to learn how to get off of Earth. I don't know if we'll still be around probably a billion years from now. We may need to get off of Earth because the sun's already going to be starting to change. So if there are intelligent people there, they better have figured out how to do space travel. So and you can't do that without going to the very beginning. So I digress a little bit. But I just wanted to mention star colors, and another great place to see star colors are in double stars. And one of the very best is also up this time of year. It's in Cygnus X1, which is in that one of the constellations in that triangle I mentioned at the beginning. But Deneb is the brightest star, which is the tail of Cygnus X1. But Cygnus X1's head, which is barely naked eye in Houston's light pollution, is a beautiful double star, very brilliantly gold and blue next to each other, and especially good in a small telescope. Double stars are one of the few areas where small telescopes excel because the colors appear richer. When you have all the brightness of a large telescope, the colors tend to wash out a little bit. So if you're a small telescope person, I recommend becoming a double star enthusiast. This will look a deep blue and deep gold in a small telescope. Now, globular clusters, we're proceeding a little bit farther along the life. These are very old stars. They're not dying yet, but globular clusters are in a different part of our galaxy. They're not in the spiral arms. There are maybe 250, 270 dotted around a halo around the spiral arm. So if you can imagine a beach ball surrounding the spiral galaxy, that's the areas where these globulars are situated. And it's one of the best things you can look at in a telescope. So you will see a dense snowball of stars. And unlike the open clusters, which are maybe 80 to 120 stars, these are tens of thousands to even up to 1 million stars. And they're a bit of a mystery. We don't know if they're left over from early galactic evolution or whether they were ejected at some point. but mostly the stars are very old, so that they can be billions of years old. And maybe there may be smaller stars that live a long time, and but they make a beautiful sight in a small telescope. So this one is M13, which is considered the best in the northern hemisphere, and Hercules is up at this time of year. So to find it, I call it, to me, Hercules is a bit of a Where's Waldo constellation, because the brightest stars in Hercules sort of blend in very strongly with all the other stars around it. But it's near the constellation Lyra. It's a good way to find it. And it's best seen for its kind of a butterfly shape. In this picture, Hercules is upside down. He has a big triangle head. He has a nice cinched in waist, and his knees are sticking up in the air, and his feet. To find, there's a butterfly shape called the keystone. And to find M13, notice that the keystone has a more angular side, and then there's a straighter side. So you have to go to the straighter side on the knee end of Hercules, not the head end, and go from the bottom star to the top, to the next star over at the waist, and go exactly 1/3 of the way down that line, and you will find M13. A lot of these things, you can start out with binoculars to get yourself oriented, and then just aim your telescope finder geometrically at these places, like 1/3 of the way between these two stars. And chances are M13 will be someplace in your eyepiece, and start out in a low eyepiece, and then you can center it, and then you can look at it in a little bit higher power. So here's a diagram showing again where these globular clusters are located. They are not where all the new stars are being formed. The two others that are the best place this time of year, which are also great beauties, are M2 in the constellation Aquarius, and M15 near the head of Pegasus, who's the flying horse. And the horses, I'll show you that a little bit later, but Pegasus's head looks very much like a horse's head. I do want to show you Omega Centauri, even though this is not the time of year for it. This is the biggest globular cluster in the sky, perhaps 1 million stars, and it's so large that some people think it might be a leftover core of a galaxy. And we are lucky in Texas because although it's in the southern sky, it can appear low on our southern sky in the spring and early summer. And it's a great attraction for people coming to the Texas Star Party. Absolutely gorgeous, even in a small telescope, especially a big telescope. Now, once you get, again, later in the life of a medium-sized star, like the sun, a yellow star, after the red giant phase, it eventually starts running out of helium, hydrogen, and even out in its outer shells. And when it starts running out of fuel, these stars, there's nothing to hold them up. So they start to collapse. And when a yellow star like the sun runs out of enough fuel, it will do a medium-sized star explosion. So it will collapse, and there will be a little white dwarf left in the middle, and the outer layers will expand outward, often in kind of an hourglass shape. We think when we're looking at the Ring Nebula, we may be looking at one lobe at an hourglass coming at us, not a circular shape of, not necessarily a circular cloud of gas. And this is very easy to find in the constellation Lyra, and it'll be on your map. So to find it, if you can see the parallelogram shape in Lyra, it's a little equilateral triangle attached to a parallelogram. Go away from the triangle to the other end of the short end of the parallelogram, and roughly halfway, it's really more like 3/5 of the way, from one star to the other is the Ring Nebula. It looked like a little Cheerio in a small telescope, a glowing white Cheerio. And it's also bright enough to show up in a somewhat light polluted sky. So it has quite a bit of brightness, but it's not large. What I like to look at after the Ring Nebula is the Dumbbell Nebula M27, because it's like a different view of like the side view versus the edge-on view of the same object. And this is one of my very favorites. If you have a small telescope, you'll see something that looks more like the right-hand picture. You'll just see the sort of bow tie or butterfly shape. As the telescopes get larger, you'll find out that that bow tie or shape is more embedded in kind of a big oval of gas. So you have more of the large telescope view on the left, the smaller telescope view on the right, and it's very beautiful. Sometimes I find the public is not all that impressed, even with something I find very impressive. But what I like to remind them is that this big kind of smudgy thing they're looking at used to look like the background stars. Then they can see what a dramatic change the star has gone through at the end of its life. So this object is not the easiest to find. I usually find it off of it's technically in Vulpecula. It's located over here. And if you have an equatorially mounted telescope, you take this little constellation Sagitta, which it's an arrow. And if you can find the star that's directly below M27, you can aim directly at that and you can move north 3 degrees. That works great if you have a telescope that moves north. I use a telrad, which is basically I'm using a geometry in the sky, and I just memorize these angles and hunt around for it until I find it. So I kind of look at how it's situated related to the constellation Sagitta to find it. And I just want to show you how it's related to Cygnus X1, which is flying this way. So if you find the Swan, and then you can find Sagitta, and then you can look sort of in between them and find M27. Now, at the very end of the life of a much larger star, what happens is you get even larger reactions, larger atomic reactions. So the sun doesn't have enough stuff in it to go beyond about creating carbon. So helium will be fused into carbon, and then it runs out of fuel, and it doesn't have the energy or the weight to crunch carbon atoms, into some of the larger atoms. A very, very heavy star like the blue star Rigel, which has so much stuff in it and burns very fast, it has enough weight to fuse some of the larger atoms into even larger atoms. And those stars will get to the point where they eventually create the element iron. When that happens, you no longer have a nuclear reaction, which is creating light and heat. It's beginning to absorb it. And once a star starts to make iron, it loses all of its oomph, its ability to hold itself up. And literally in a few minutes, it will collapse and then explode. And in the middle will be a lot of the star, will be what we call a neutron star. So the white dwarf, let me go back to that, would be like most of the sun collapsing to the size of the Earth. A supernova remnant, or a neutron star in the middle of a supernova, is so dense, what's happened, the electrons been stripped off of the protons and literally crunched together. So you only have neutrons. So the space in the atoms is completely gone. In that case, most of the star that's in the middle is now the size of maybe Texas. It's a very small, maybe a country or a state of Texas. It's extremely small. It's rotating sometimes many times a second. And the rest of the star has exploded outward into a supernova remnant. That happens about 3 times, maybe every 1,000 years in any one galaxy. So most of the supernovas that we see actually happening real time, we see them in other galaxies. If one happens in your own galaxy, it can be seen during the daytime. So the Crab Nebula is a remnant of a supernova that went off in 1054 AD. The Chinese recorded it. For a few months, it was visible during the daytime. It was that bright. And ever since then, the explosion's been continuing. And now what we see is a faint smudge. And there are amateur astronomers. Actually, one of our members, Richard Nugent, had a project of photographing the Crab Nebula every year for 10 years. I don't have that GIF right now, but people are actually photographing real time that this gas is continuing to expand. You can see it change over time. So you're looking at an explosion still in progress that's been going on for about 1,000 years. In a small telescope, it looks a little bit more like like what you see at the right. Sometimes it looks like a kind of a little bit of an S with a fat center. So it is near towards the bull's horn. So if you take go away from the Pleiades, take one side of the V and go to a star over here, and then look just slightly toward the other star, the other horn, go just a little notch, and that's where M1 is. The other spectacular supernova remnant to look at in the northern sky is the Veil Nebula in Cygnus. You do need a dark sky. It's wonderful in a place like the Texas Star Party in West Texas or near McDonald Observatory. And there is a star in Cygnus that's not one of the main parts of the constellation, but it is naked eye if you're in a dark sky. And all you have to do is aim at that star and the Veil Nebula will come up. It helps with the Veil Nebula to use a filter, a deep sky filter will bring out its filaments a lot more. So we think these filaments are like looking at a warped window screen. You would see if you took a window screen and kind of bent it a few times and then looked at the edge on, you'd see different densities of window screen. That's the way I've heard the Veil Nebula described, and there's a couple sections of it, but we're probably looking sort of edge on at edges of supernova explosion. This next supernova that might go off is Eta Carina. It is a southern sky object, but that one is literally, could happen now, it could happen 100 years from now, it could happen 1,000 years from now. But when it goes off, it'll have a great impact on us. And it would be like what the Chinese saw. It would be a naked eye in the southern hemisphere. So this one, Betelgeuse, maybe might go off. They were wondering when it dimmed last year whether it was starting to change. Now they think it was just dust. These are unstable stars toward the ends of their lives, and they will be very large stars, which will go supernova. Now, the neat thing about supernovas is that's where all the other elements are made beyond iron. That happens during the collapse. So the star is no longer holding itself up, but as it collapses very suddenly, all of the heavier elements are made, or uranium, everything that the Earth is made of, that rocks are made of, that people are made of, is made in supernovas. You cannot have people or planets with all of these heavier elements without having some stars that lived first before us collapse, spewed out all these elements into a new hydrogen H2 region, and then new stars could form. That's why there's sort of a second generation of stars. And now you can have planets and people. So if you go for an even larger star, it can possibly collapse beyond the neutron star stage, collapse out of existence. And black holes were, when they were first postulated, we thought, well, how in the world would you find them? Well, they were theorized to emit X-rays when things fall into them. And the very first black hole found was Cygnus X1. And there were two signs that might be a black hole. One was that they saw a star appearing to rotate around nothingness, and something that should have had a lot of mass, except you couldn't see it. And the other thing was that there was a very strong X-ray source. So Cygnus X1 was the first black hole detected. We think that black holes are literally distorting mass and space-time through intense gravity, which keeps growing as things fall into it. And that gravity, which is basically warping the shape of space, is so strong that even a light ray, if it were to try to escape from the black hole, it would just double back in space and fall back in. So there's no way to get a view of light out of the black hole. It probably behaves a little bit like a coin funnel. Things fall in and they don't come back out again, but things can spiral around the black hole before they fall in. And so again, here's sort of a schematic of it, of what and they can be, we think they can be either large stars that collapse. We also think there are black holes in the cores of galaxies, which are millions of stars that have all collapsed into this black hole, and possibly in the middle of some globular clusters. So here's a GIF of things falling into a black hole. What we call the event horizon is not really the edge of the black hole, but it's the edge of where light is no longer visible. Now, M15, when I did this talk the first time, it was thought to have a black hole in it. Now I understand they go back and forth. The reason it's thought to have a black hole is it has an exceptionally dense core compared to other globular clusters. So there's two theories. One is that it has a black hole, a medium-sized black hole in the middle of it that might be fewer stars than, say, the Milky Way galaxy has in the middle of it, fewer stars composing its gravity. But, or some theorize that it's maybe just a dense core of stellar remnants, stars that have lived and died, and they've just kind of all collected there at the core. So the Milky Way, we are pretty sure harbors a massive black hole. Now, how would you know that? It's because of years of observation of stars near the center, measuring their position and seeing how they move. And this is what they came up with. So notice that star, especially whipping around it. You don't really see anything there, but you see its effect on the stars near it. And from that, they can calculate its gravitational mass or its mass. And they estimate it might be the mass of, say, 4 million stars. We can also detect black holes from their effects on the things behind it, called gravitational lensing. So it might, the gravity of black hole may distort the light that's coming from behind it as it's hitting us. So I'm going to go once again back to our evening sky map. I don't know if you guys can see my cursor. I don't know if Joe's there. But,
we can see it.
Okay, I just want to mention some things I'd mentioned. So I mentioned on the globular clusters, I mentioned M15. Pegasus, the horse, has a very easy to see empty square of stars. And out of one corner, there's 1, 2, 3, 4 stars that make like a very strong horse head shape. It's the opposite corner from Andromeda over here. And if you follow the horse's neck to his nose, you go the same direction, you run into M15. M2, which is the other really nice globular, is located near Aquarius. I just kind of find it from the shape of Aquarius. There is a diamond head and kind of a peace sign over here. And you'll have to use your map to find Aquarius and M2. Here's the summer triangle. Here's Cygnus the Swan. So M27, it doesn't show Sagitta here because at this resolution, but M27, the dumbbell, is over here. Near Vega, again, here's Vega's a bright star. That's actually part of the triangle part of Lyra, but there's a little tiny parallelogram, and in between the short side away from Vega, halfway between, that's where M51 is. Here's Cassiopeia, the W shape. Again, take the left side of the W down and go a little farther, and you find Phi Cassiopeia, the little star cluster that looks like ET, the extraterrestrial. Here's the Andromeda Galaxy. Let's see, there's my cursor. Again, you've got these two cascading curves of stars, and you take the second pair and go toward Cassiopeia, exact same distance, exact same line, and you come to Andromeda Galaxy. 253, the galaxy that really looks like a galaxy, is down here, and hopefully we'll be getting a little bit higher. And since this is a Northern Hemisphere map, it's actually more keyed for New York. So already this area farther south of New York is a little bit higher up in the sky. It never gets terribly high, but it's a fabulous object to look at if you have a dark sky, say at our astronomical site, and a good sky to the south. And I think that's the double cluster in Perseus. So I don't like the way Perseus is drawn here, but the double cluster there's sort of a head. I look at two strings of stars in Perseus. There's a head of Perseus, and between that head and a side of Cassiopeia is a double cluster. It's prominent enough that if you can just get your telescope in the general area and hunt around, these clusters will jump out at you in the dark sky. And here's Sagittarius, which we're about to disappear, but this is where some of the summer objects are that I told you about. And Jupiter and Saturn, don't forget to look at them. Now's a great month to look at them or to show them to kids. You don't necessarily need to see the constellation Capricornus. You just need to know that to look due south. And the brightest thing you'll see will be Jupiter. And next to it and fainter will be the next brightest thing you see. Well, considerably fainter than Jupiter, but definite will be Jupiter and Saturn side by side to the south. And I just wanted to end with a beautiful picture of the Milky Way from Lowell Observatory. When you're looking at the Milky Way, you're looking at the galaxy edge on. So when you go to a dark sky and see this kind of faint haze going across the sky, you are looking at the spiral arms from the edge, as opposed to when you see all the other constellations, you're looking up and down out of the spiral, up from the spiral arm, down from the spiral arm. You're not looking along the spiral arms. So I often use this picture. I'll just briefly mention, I have a letter today in the Houston Chronicle. We have a terrible problem with light pollution. And I heard from the city councilwoman, Martha Castex Tatum, after I sent her the letter saying she wants to work on this. She's been one of our greatest supporters on city council, along with Sally Alcorn, I think David Robinson, who's an architect. And I am very concerned that Houston's white lighting is getting so intense that we are wiping out the stars. But Lowell Observatories near the city of Flagstaff, they have very careful LED lighting that's amber colored, and their visibility is excellent on the ground. This observatory is only 6 miles away. You can see a few lights down here. They just don't put any light into the sky. They can see in the city, it's 107,000 people, and yet they can see the sky. Houston may not have to go as very careful as, we may not be able to. Be nice, it would do it, but I don't think they get the support to do that. But there is appropriate city lighting, which is warmer, from warm white down to amber. And I've seen maybe 4 or 5 cases in Houston. There's a Denny's at 12405 Westheimer near Derry Ashford, where you can look directly at the warm LEDs in their parking lot on poles. And it doesn't hurt your eyes at all. There's some Shell stations that have beautiful lighting. And we are way behind many other cities. So I have some great pictures at a website called www.softlighthouston.com. If you see the internet version of my letter, if you have a subscription to the Chronicle, I had sent them some references, and they actually have 5 references in there, 3 of which I sent, the other 2 I happen to have. And they really went to town on it. So they wrote me, said they had seen that I'm interested in astronomy and lighting, said they would love op-eds on one or both. They said they'd be interested in light pollution and astronomy. So maybe we can get something going in the Houston Chronicle finally. I think they're finally noticing we have a problem. And that's the end of my presentation. So I'm going to stop the share now.
Great presentation, Debbie. Thank you very much. I was on the Big Island of Hawaii 2 months ago, and the lights there were amber, almost yellow in many places. And, it's not nearly as bright, and the glare wasn't nearly as intense as it is here in Houston, but you could still see everything. It was really amazing that how much you can see without all of the extra light. So with that, we'll go to some of the questions. So Wayne Turner actually had 2 questions. Wayne, do you want to come off mute and ask your 2 questions?
Yeah, I'm sort of in the dark.
There you
go. Let me see. Yeah, the Pleiades are in the Milky Way, right?
Right, yes, they are.
Yeah.
Right, so anytime we're looking at an open cluster, we are looking within the spiral arms of our galaxy where stars are being formed. So those are, I tell kids, they're more like children's stars. A lot of the gas has been used up, but the stars are still gravitationally attracted to each other. So you see the stars minus the gas that were made of. The Pleiades, actually in large telescopes, there is a little bit of gas still left over, but in a small telescope, I can't see it. I just see the stars.
Yeah. And I have another question somewhere here. Why don't somebody else go with another question?
Okay. The other thing I wanted to mention, and Debbie, chime in on this, when we're looking at things in the night sky naked eye, just about everything that we see is in our own galaxy, with the exception of, if you're in a dark sky, you can see in the Andromeda Galaxy, Triangulum, if it's really dark, and that's pretty much it. Everything else is in our own neighborhood here in the Milky Way galaxy.
Right. So about 100 years ago, people thought we only had our galaxy. It's amazing how much the universe has expanded as far as our understanding of it. So it wasn't until we got a little bit better at measuring distances. Eventually, someone realized, or Hubble realized, that some of these smudges that we were looking at were actually other galaxies. They were calling them nebulae. They thought they were just gas. And now we know that they are galaxies like ours.
Yep. All right, Wayne Turner had a question, or excuse me, we went to Wayne. Gerald Klein, sorry, Wayne. Gerald, are you there?
Yeah, hi. Can you guys hear me?
Yeah, we can.
Great. Hey, Debbie, really appreciate the presentation. Really nice. Had a couple of questions. First up, what's on your observation list for the new moon coming up next week? And then second, you know, I live out here in Tomball, where we've got light pollution as well, maybe a little bit less than the city of Houston, but would like to know what are the best ways we can engage some of our local city councils? What would you recommend we do to start out with dark sky advocacy?
Well, two things. One problem, I found a hole in dark sky advocacy. And because I was writing the International Dark Sky Association, where LEDs were going to have, what was very difficult to find, especially since we didn't have any in Houston, was pictures of LEDs well used. So amber LEDs, I've now finally traveled. I've actually, it's taken me years. I saw my first warm LEDs of any kind in Geneva, Switzerland. But I created a website called softlighthouston.com. There's a gallery there, and there's no one who looks at like the good versus the bad lighting, who prefers the bad lighting. So I found that a picture is worth 1,000 words. The other thing is that we use I actually have a lamp here. We use this lamp. It's not plugged in right now. It's a non-astronomer said, you've got to get this lamp, who I'd convinced on the lighting. And it has 7 brightness levels and 5 colors, from a very blue white to a warm white. Mm-hmm. And you'll see at the bottom of my education page a kind of picture on my dining room table of 2 of the pieces of demonstration. What I like about it is if you see someone in person, and they'll work in an auditorium, people see real light. With photographs, it's very hard to really show how people see it. When Steve Goldberg's been helping me a lot with photographs, mm-hmm. when we will doctor them, don't do this. This is the same camera setting, because you will actually shoot yourself in the foot. The camera does not see it the same way you do. So we did, there's a Westbury Community Garden retrofit, which is also on the gallery, thanks to Steve Goldberg. And that, first of all, that one retrofit is a great example of proving that you see more with less light. So you will see the before, which is 80 watt, you know, the white wall packs with the glare, they're unshielded. And you see all these apartment complexes with the huge, the white glare, but you don't see anything else. You see white glare and black building. And then those were 80 watts. And then the garden bought 32 watt lights, which were warmer and shielded. And it was this great design that they discontinued due to lack of demand. Their best lights, this is a Econo light, there's a whole page of discontinued beautiful lights for our purposes. And I called them, they said, well, there's no demand for them. People are asking for the glare. That's why I wrote my letter. And first of all, the lamp, there's 100% are convinced that a warm, faint light is much more beautiful and much more relaxing, and that you will see better. So I use a figure underneath it and behind, and that behind figure is really pertinent, because you see the figure in front underneath it, no matter how bad the glare is or how good the light is. Well, the big difference is the guy behind, huge differences. And I can get them to hold their hand up and block the light, and all of a sudden the guy behind jumps out at you. So it's perfectly sized, sort of like a street light where kids' action figures or McDonald's Happy Meal toys work beautifully. And go ahead and use toys. And I always explain a way so they will take me seriously. I say, this is also showing you the color rendition. So police have said, well, we want the whiter light because we want people to know whether a red car or a blue car hit them. The color rendition is fine on a warm white. And it's also actually quite a bit better with LED amber color, which is similar to the old lights we have. I finally found a picture. Salt Lake City, Utah is going to use warmer street lights. And they have a photo on their website about the LED street lights. They have a big PDF. And it's a red car. And on one side is lit by an amber LED. And on the other side is lit by amber high pressure sodium, like the other lights. And so half the car is brown and half the car is red. That is a great picture to show them that even amber light, which is the best for astronomy, you're not going to lose your ability to see color. There is a narrow band amber, which is what they use in Flagstaff, which can be filtered out by the professional observatories. That's great for sea turtles. It's probably not practical, a little bit more expensive. You get less light per watt. Not as practical for big cities, but for small towns it's great in very sensitive areas. there's also more broadband ambers, which will be more palatable to cities.
Right.
So go to my website, and I'm going to give a talk at Fort Bend, and I'm going to write an op-ed. But the lamp demonstration is the best thing we have visually, and the website are highly convincing.
Thank you.
All right. In the comments, Don Adams didn't have a question, but he mentioned a course that he's taking from the Big Bang to dark energy. Go look at that in the comments, and if you're interested. He does mention it's a free course, or if you want the certificate, there's a fee for that. Other questions? Somebody had asked for the link to the op-ed. I had that there. Serbi, I pasted that in the chat itself. And Sanjay asked a question. Sanjay, do you want to come off mute and ask your question to Debbie?
Yeah, sure. Hi, Debbie. Enjoyed your presentation. In your presentation, you referred to in small telescopes, it looks this way, and in larger telescopes, it gives much better view. My question first was, where do you draw the line? Is it 8-inch and below is small, or something even smaller?
What you do is you look at the right objects for your telescope. I use a 5-inch Celestron classic orange 5-inch telescope for 20 years. I think the sky was a little darker too when I was using it. But every single thing I showed you tonight, I found impressive in my 5-inch telescope. I now have an 8-inch telescope, and I have an 18-inch that I bought more recently. So the 18-inch galaxies now finally look like galaxies. I'm actually seeing knots in the arms. And my 5-inch only NGC 253 really looked galaxy-like. The others were like small to indis. You can see the basic shape. There's only a few galaxies. There's a Sombrero galaxy that looked really impressive. But what you do, there's almost, I would not go much below 5 inches to really look at deep sky. But I actually prefer double stars in my smallest telescope. They're more brilliant. The color contrast is stronger. It's a much prettier view of, I get disappointed when I look at double stars in the larger telescopes. So it just depends on what you're looking at. There's some objects that only the binoculars are the best way to look at them. So eventually people get a menagerie of telescopes, but if you only get one, I'd say maybe the 8 to 12 inch, if you're looking for a balance between what you can see and transportation, that's a great range. My 18-inch is an ultra compact. I can collapse it, but it is a big to do to set it up. So, but it will actually fit my Ford Fusion hybrid. It breaks down enough to do that. I can put it in a sedan and take it to the Texas Star Party.
Okay, great, thanks. I had a follow-up question. What are some of the tips that you may have for us trying to do some astronomy from our backyard in, like you did Houston?
Yeah, so I actually just lost some stars again in Houston. A lot of businesses have been putting up incredibly bright light. I thought it had gotten as bright as it was going to get, and it's getting incredibly bright. So in Houston, there's only a few things you can see well, but I will often do planets. The moon is fabulous, and some of the brighter, you can see any double star, but you just need to be able to see the outline of the constellation well enough to find the double star in the first place. So Alberio is usually barely naked eye in Houston's glare. I'm hoping I can still see it after some of the businesses around me. But it can be found geometrically also, how it relates to the rest of the summer triangle. And that's really impressive in Houston. So double stars are good. Some of the brighter star clusters will show up. But I found ET, I was able to show it on Halloween. I had the city put in a house side shield for my very bright street light. That brought back ET last Halloween. Halloween, by the way, is coming up. This Halloween, we're blessed with Jupiter and Saturn. I absolutely adore taking my telescope and the candy out front. And my first choice is Moon, Jupiter, Saturn, if any of those are up. And second, and if I don't have any of those, I go to ET, I go to Phi Cassiopeia, because it looks like a star cluster. In my 8-inch, I can see it in my front yard last year, or a couple of years ago. I didn't do the pandemic. I don't know whether I might have lost it with the new LED lights and the businesses around me.
Yeah, the one piece of advice I would give is, even in the city, I live pretty close to downtown by Memorial Park. If I can find a place away from the glare of the streetlights, that makes a huge impact. Even with the additional light pollution, there are things that you're just not going to be able to see. But if you can get away from the glare, it helps at least helps me find those objects or those stars that may be just on the cusp of being visible from the city, and certainly allows me to navigate to what I need to find.
So a fence, like a fence or a car or something,
Right,
that physically blocks out
exactly.
the direct glare from the light.
Yeah.
Okay, great. Thanks.
All right. And then Carlos Areu, a great plug here, says EAA, which is electronically assisted astronomy, is a great option in light polluted skies. That is absolutely true. And we just started a special interest group to learn more about EAA that Carlos is heading up, and we'll have our first meetings in mid-October. So great to know that that's coming down the pike, and great plug there, Carlos. Does anybody else in the crowd have any questions that they want to ask Debbie? That was the end of the questions that we had in chat.
Yeah.
If you do, feel free to come off mute. Yeah, go ahead.
The question I had was, can we identify the supernova that formed all the stuff that ended up making our planets and such?
I don't know the answer to that question. That is a great, I mean, it would have been an awfully long time ago. The sun is 4.5 billion years ago. But I guess, yeah, I don't know if we could, Joe, do you know anything about that? If we could identify the specific star, and we know we came from a specific cloud of gas, but
right. No, I think they're still trying to figure out what other stars were born out of the same gas cloud there, right? And they've done some mapping to figure that out based on stellar ages and trajectories and things like that. But yeah, not sure if we can get to that level of investigation in terms of what star that this all came from.
Right. Yeah. The Crab Nebula is only 1,000 years old, and we're 4.5 billion years old.
We're at the scene of the crime, and we still don't know who did it.
I think we're past the first 48. So. All right. What other questions do we have out there? Feel free to come off mute and ask. Okay, not hearing anybody. Come on, so we'll go ahead and wrap up here. Debbie, once again, thank you so much for the presentation tonight. It was a wonderful talk, and I learned a lot, like I always do, anytime you give one of these presentations. So thank you very much.